Welcome, everyone. If you're prepping for your general science and ability paper, you already know that some topics are just, well, they're more critical than others. The hydrosphere is definitely one of them. So in this explainer, we're not just going to cover the basics. No, we're going to build the kind of analytical framework you need to turn a good answer into a really great one. Let's get started.
So here's our game plan. We'll start with the fundamentals, right? What the hydrosphere even is and the water cycle that keeps it all moving. Then we'll shift gears into some critical analysis, looking at humanity's footprint and, really importantly, how these big global issues create specific, urgent crises right here in Pakistan. And we'll wrap it all up with the key takeaways you're going to want to have locked in for exam day.
All right, Section 1. What is the hydrosphere? Look, before we can even begin to analyze the problems, we need a precise, rock-solid definition. This is the foundation for absolutely everything that follows, so let's make sure we nail it.
Now, the definition itself seems simple, but its implications are huge. You see, the hydrosphere isn't just the oceans. It's the glaciers up in the Himalayas, it's the clouds that bring the monsoon, it's the rivers that are our absolute lifelines, and it's even the hidden groundwater deep beneath our feet. It's all of it, in every single form.
This chart right here, shows us the most critical fact about our planet's water. Just look at that number. Over 96% of it is salt water. And that tiny fraction that's freshwater, well, most of that is locked away as ice. This leaves an incredibly small amount that's actually accessible for us to use. You know, this single concept, the sheer scarcity of usable freshwater, is the key. It's the key to unlocking almost any exam question on this topic.
Okay, on to our second section, the global water cycle. If the hydrosphere is all the planet's water, then the water cycle is the engine that keeps it all moving. And understanding this engine, it isn't just about memorizing steps, it's about seeing the fundamental process that makes life on land even possible.
So these 5 stages are in constant motion. The sun's energy drives evaporation from the oceans, right? That water vapor condenses into clouds, and precipitation brings it back down. On the ground, you've got infiltration, which is the water soaking into the soil, and percolation is its deeper journey down to recharge those underground aquifers. Anything that doesn't soak in just becomes runoff. Grasping this dynamic loop is crucial for explaining everything from climate patterns to agriculture.
So, we know how the water moves, but where is all this water actually stored? That brings us to Section 3, Earth's water reservoirs. Let's break down where the water is, and, more importantly, in what amounts.
We've seen this number before, but let's think about its biggest implication. This huge ocean reservoir isn't just a big bucket of salt water. It is the planet's main climate regulator. It absorbs and stores massive amounts of heat, basically acting like a global thermostat that shapes weather patterns all over the world.
So here's the crucial point. The components we depend on the most for our day-to-day survival, freshwater lakes and rivers, they make up a tiny, tiny fraction of the total. And notice how groundwater is also a really significant, though often hidden, freshwater resource that's stored in these underground aquifers.
And this is exactly why the ocean is so critical for our climate. It's not just some static pool of water. These currents act like a giant global conveyor belt, moving heat from the equator up towards the poles and circulating nutrients. This global transport system is a vital part of what keeps our planet's climate stable.
Okay, now we need to pivot. We're moving from the natural system to how human activity completely disrupts it. A good CSS answer never just stops at description. It has to move to analysis. The examiner wants to see you connect these natural processes to what we call anthropogenic impacts, fancy word for the effects caused by us, by human beings. The first major human impact is the degradation of water quality. And we're not just talking about dirty water here. We're talking about specific contaminants. Things like heavy metals from industry, pesticide runoff from farms, and even invisible threats like microplastics that are now everywhere in our water systems, making them unsafe.
The second impact is an issue of quantity. We are pumping groundwater from aquifers and diverting rivers at a totally unsustainable rate, usually for agriculture. We're essentially using up this resource much faster than the water cycle can replenish it. It's like we're mining a finite resource, and that's creating long-term scarcity.
And the third kind of overarching impact is climate change. You should think of it as a threat multiplier. It basically supercharges the water cycle, which leads to more extreme and unpredictable weather. It intensifies both droughts and floods, and it's fundamentally reshaping water availability all across the globe.
So let's bring all of this home. How do these huge global pressures actually show up as specific, tangible crises in Pakistan? This right here,
This is the application part of your answer that is going to score the highest marks.
For Pakistan, the hydrosphere isn't some abstract idea. It is the Indus River system. Those glaciers we talked about, they're the source of the Indus. The rivers, they're the backbone of our agriculture, our economy, everything. So the threats to the water cycle, they aren't abstract either. They are direct threats to our national survival and regional stability.
You know, Pakistan faces this cruel paradox of getting both extremes you see here. On one hand, climate change can cause more intense, more erratic monsoons and faster glacial melt, and the result? Devastating floods. But on the other hand, shifts in these same weather patterns can lead to long periods of low rainfall, which causes severe drought. It really is a story of too much water and then suddenly not enough.
Okay, let's pull this all together. Section 6, Key Exam Takeaways. These are the core concepts you absolutely need to have ready to go for your exam. Seriously, if you remember nothing else from this entire explainer, remember these 5 points. They form the analytical backbone for any question you'll get on the hydrosphere. Start with scarcity, explain the process, analyze the human impact, apply it directly to Pakistan, and then show how the resulting crises like floods and droughts are all interconnected.
And that leaves us with a final thought to really chew on. This question moves from pure science to policy and national security, and that's exactly the kind of integrated, critical thinking the CSS exam demands. It's not just about what the hydrosphere is, but what we absolutely must do about it.